Hello, this is Maria from mathmammoth.com. In this lesson, we're going to look at some more things about inequalities. And my first example is negative 3x is greater than 9. Now, if I start solving this thinking of the corresponding equation, negative 3x equals 9, the way this is solved is we divide both sides by negative 3 and get x equals 9 divided by negative 3, which is negative 3. So if I solve the inequality the same way and divide both sides, I would get x is greater than negative 3. But there is a problem, and we will see that if we start checking this solution. To check an inequality, I would take some example values. For example, let's say I set x to be 0. If x is 0, then x is indeed greater than negative 3. It is in the solution set. 0 is in the solution set. All the numbers that are greater than negative 3 are in the solution set. So 0 and negative 1 and 1 and 2 and 3 and many more. So this should fulfill the inequality. But what happens? Negative 3 times 0. Is it really greater than 9? Is 0 greater than 9? Not at all. So the check fails. There's something else going on. Let's find out what. Now, there is a trick that I can solve this without coming up with this division by a negative number. And that is that I can add 3x to both sides. Let's see what happens. I add 3x to both sides, and then over here I get 0. Now I subtract 9. Now I divide by 3. So actually, x is less than negative 3. All the values of x that are less than negative 3 is what I get as a solution set now. But originally I had x greater than negative 3. All the values of x that are greater than negative 3. And now I've got all the values of x that are less than negative 3. And if I check, for example, let's say I take some number that is less than negative 3. Let's say negative 5. So over here, if this is negative 5, I get 15. That is more than 9. It checks. Or if x is, say, negative 10, then I get 30. Yeah, it's greater than 9. If x is negative 4, this becomes 12. Yes, greater than 9. It works. The shortcut for solving inequalities when you have to divide by a negative number is that you, at the same time, flip the sign, the greater than or less than sign. And then everything works. So let's use that. You flip the greater than or less than sign when you divide by a negative number. Here, negative 4x is less than 20. I divide by negative 4, so that leaves x alone. Then I flip this sign and calculate 20 divided by negative 4, which is negative 5. So the solution set is all numbers that are greater than negative 5. Let's look at this example. Here we will start out by subtracting 3. And that leaves minus 5x, and 33 minus 3 is 30. Now we divide by negative 5. That leaves x alone. And we flip the sign, like that. And 30 divided by negative 5 is negative 6. And that is our solution set. All right, here's a little bit more involved inequality. Try to solve it yourself. The first thing I would do is to combine these two terms that have x. So x plus negative 6x, that would be negative 5x. And then the plus 2. And I would simplify this to get negative 1. Okay, now I want to isolate this term, so I will subtract 2 from both sides. And then divide by negative 5. I'm dividing by a negative number, so I flip this sign here. And I get, okay, negative 3 divided by negative 5, it's going to be positive 3/5. All right, I hope you got the same. I already talked about this a little bit, but let's look at it a little bit more now. How to check the solution set or the solution to an inequality. You cannot check all the possible values of x because the solution set is infinite. It has tons and tons of elements in the set. But you take some examples. So, for example, here's an inequality that somebody solved, maybe me, and this is the solution set, all values of x that are less than -1/4. To check it, I will choose some values near -1/4, but on both sides. So I might check, for example, some numbers that are less than that would be -1/2, -1. Some numbers that are bigger than that, well, 0 is always our easiest one to check with, and 1. So let's check with those. First of all, -1/2. I will plug it into the original inequality. And we're checking whether that is indeed greater than 24. Here I have 16 times -1/2. That's going to be -8. So all in all, 20 minus -8, 28. Checks. Okay, -1 then. 20 minus 16 times -1. Is it really greater than 24? Here this is -16. Minus -16 is going to be an addition, so we get 36. It checks it was true, and here also. So for these two values, the inequality was true. Then let's take 0. Now note that 0 is not in the solution set, because the solution set is numbers that are less than -1/4. 0 is not in that set. That means that the inequality should not be valid, or not be true. 20 minus 16 times 0, is it really greater than 24? Well, this is just 20, and 20 is not greater than 24. It did not check, but that's what we wanted, okay? Because 0 is not in the solution set we got. And then lastly 1. 20 minus 16 times 1. Is it really greater than 24? This is 16. 20 minus 16 is 4. No, 4 is not greater than 24. So again, a number that is not in the solution set, it does not check the inequality. The inequality is not true. And that's what we wanted. So our check is complete for those 4 values and everything went well. These two that are actually less than -1/4, they fulfilled the inequality, and these two did not. All right. One more. There's an inequality and a solution set. Is the solution correct? Check it yourself. Inequality, and then it says that, well, x, all the values of x that are greater than 3/8. Again, we will choose some values. I always want to choose 0. In this case, 0 is not in the solution set, so this should not be true for 0. And then some other numbers that are nearby on both sides of 3/8. So for those that are bigger than 3/8, we could choose 1 and 2. Those that are smaller, we could choose 0 and -1. I'm going to start with 0 though. 0 is not in the solution set, once again, so this should not be true if this was solved correctly. 5, is 5 really less than 3 times 0 minus 11 times 0 plus 8? Well, 5 is less than 8. 0 fulfills this inequality. But here, the way this person solved it, 0 is not in this solution set. So the solution set is not correct. The solution is not correct, okay? We only needed to check 0 and find out that, okay, this is not solved correctly. This solution should include 0, whatever it would be. Maybe it would be x greater than -1 or something, so that 0 would be included in the solution set. Okay, we're all done with this. I hope it was helpful.